In this lesson you will be shown how to solve simultaneous linear equations, that is, two equations with two unknowns. The method used will be the elimination method. Here is a typical problem that might be solved using simultaneous equations. The first statement could be written as an equation: 1 water plus 3 polos equals 175 pence. Similarly, the second statement could be written as 3 waters plus 3 polos equals 255 pence. If we subtract one equation from another, because both equations contain 3 packets of polos, all we are left with is 2 waters, and subtraction of the amounts of money leaves 80. If 2 waters cost 80 pence, then 1 water is equal to 40 pence. In the next few examples, we will investigate a little further how we might do this in a more mathematical way and without the context. Consider the two equations shown. Note that the x coefficient, that is the number before the x, in both the equations is the same, 2x. This means we can subtract one equation from the other and eliminate the x's. So if we subtract 2x from 2x, we'll have nothing. Subtracting 2y from 5y gives us 3y, and subtracting 6 from 12 leaves us 6. Therefore 3 lots of y is equal to 6. This can be simplified further to give y is equal to 2. We have now found the value of y. We now need to go back to the original equations and find the value of x. We can do this with either of the two original equations. 2x plus 2y equals 6 looks easier to work with, so substitute y equals 2 into 2x plus 2y equals 6. 2y has a value of 4 if y is equal to 2, therefore the equation is written 2x plus 4 equals 6. Subtracting 4 from both sides gives us 2x equals 2, which means that x is equal to 1. So the solution to this simultaneous equation can be given as x equals 1, y equals 2. In this example, note that the y coefficients are the same numerical value 4, but one is negative and one is positive. That means we can add the two equations and the y terms will be eliminated. Adding the 2x and 3x gives 5x. Adding minus 4y to plus 4y gives 0. And on the right hand side, 2 add 13 is 15, giving us 5x equals 15. and therefore x is 3. We can substitute x equals 3 into the second equation, 3x plus 4y equals 13. As x is worth 3, we get 9 plus 4y equals 13. Subtracting 9 from both sides, we get 4y equals 4, and therefore y equals 1. The solution is therefore x equals 3, y equals 1. In a practical situation, it is unlikely that our coefficients for either x or y will be the same. So we may need to make some adjustments to one or both of the equations. We would multiply in order to achieve this. In this example, you can see that the x coefficients are 2x in the first equation and 1x in the second. If we multiply the second equation by 2, then the x coefficients will be the same in the original equation and our new equation formed from the second one. So multiplying the second equation by 2 gives 2x plus 6y equals 22. We can then work with this one, and the first equation, 2x plus 2y equals 14. As the x coefficients are the same, we can now subtract the equations, giving us 4y equals 8, and therefore y equals 2. We can substitute y equals 2 into any of the three equations that we now have. The simplest one looks to be x plus 3y equals 11. Substituting y equals 2 into this gives x plus 6 equals 11, and therefore x is equal to 5. Our solution is therefore x equals 5, y equals 2. In this last example, we will look at the situation where you need to multiply both equations in order to achieve one set of coefficients being equal. In our first equation, we have 3x at the front, and in our second equation, we have 5x. If we multiply the first equation by 5, that is the number that is the x coefficient in the second equation, then we'll get 15x. If we take the second equation and multiply that by 3, we will achieve 15x again. So we therefore multiply the first equation by 5 and the second equation by 3 to give us two new equations. 15x minus 10y equals 0, and 15x minus 9y equals 3. As we now have two equations with 15x as the x coefficient, we can subtract. Here we need to be careful with the negatives. Negative 10y minus negative 9y is the same as saying negative 10y plus 9y, giving us negative y. 0 minus 3 gives us negative 3. So negative y equals negative 3, or y equals 3. Substituting y equals 3 into any one of the four equations we now have would give us our x result. In this case, 3x minus 2y equals 0 looks to be the simplest. So putting y equals 3 into this equation, we get 3x minus 6 equals 0, giving us x is equal to 2. Our solution is then x equals 2, y equals 3.